Okay, so the probabilities the students A, B, or and C can solve a particular problem are given, respectively. Okay, if they all try, determine the probability at least one of the groups solves the problem. Now, when we see problems of at least one, okay, there can be lots of different combinations to work out. So at least one in this case would be that one of them solves the problem, or that two of them solves the problem, or that three of them solves the problem. So we'd have to do all those events separately and then add them up, obviously. But an easier way to do it is to do the complement. So the complement of this event, at least one solving the problem, the complement to that will be that no one solves the problem. Okay, so we can set our problem up like that instead. So the probability that at least one solves it will be equal to 1 minus the probability that no one solves it. Okay, so what will that work out to be? So that will be 1 minus the probability that A doesn't solve it, and B doesn't solve it, and C doesn't solve it. So the complement of A, B and C. So that will be 1 minus A not solving it will be 2/5 because it's 3/5 that he does solve it. B not solving it will be 1/3, the complement of what's there. And C not solving it will be a half. Now notice these figures are the complements. So this is 3/5 for solving it. Okay, so for A, it's 3/5 for solving it, so 2/5 for not. For B, 2/3 for solving it, so 1/3 for not. And A or C, then the last person has a 50-50 chance, so that's obviously a half in either direction. Okay, so working that out then, it gives me 1 minus 1 over 15, which is equal to 14 over 15. So like I said, the at least problems tend to be easier to look at from the other perspective.